Welcome to this explainer. Look, if you've been working in tech lately, you absolutely know the drill. We've all seen those flashy, flawless AI demos that make building an autonomous agent look like absolute magic. But speaking as a technical lead, let me tell you, there's a massive and frankly dangerous illusion at play here. There's a world of difference between a prototype that works perfectly exactly once and a real-world deployment that can actually survive the chaos of production. Building a successful AI agent requires so much more than just grabbing the newest, shiniest foundation model off the shelf. It requires engineering a rock-solid, highly reliable system completely wrapped around that model. So let's dive into this and strip away the hype.
Right out of the gate, we run into a trap that I see enterprise teams fall into constantly. The project kicks off, everyone is super excited, and literally the very first thing someone asks is, hey, can we build an AI agent for this? Or can we use GPT for this? Now, this is exactly the wrong starting point. Instead of asking what measurable business problems we're actually trying to solve or what specific decisions the agent needs to be making, teams start with a naive technology question. And honestly, that is just a recipe for disaster.
Because this is the core conflict we're dealing with, the demo versus the production reality. In a demo environment, your objectives can be totally loose. It's fine. But in the gritty reality of an operational system, if your objectives are vague, failure is practically guaranteed. Without clear, hard targets, evaluation becomes completely impossible. And when things eventually break in production, and trust me, they will absolutely break, those failures become incredibly difficult to diagnose. Why? Because you didn't even know what success was supposed to look like in the first place.
To save you from those frantic 3 a.m. debugging sessions, here is our battle-tested production readiness checklist. Number 1, the foundation. Number 2, brains and boundaries. Number 3, the operational reality. And number 4, the human safety net.
Let's start with Section 1, the foundation, goals and reliable tooling.
So without a rock-solid infrastructure and measurable targets, your agent is going to fail. It genuinely doesn't matter how incredibly advanced your foundational model is. An AI agent is only ever as capable as the tools it is permitted to use and the parameters it operates within. A vague goal sounds something like, let's automate this workflow, right? But a true production goal looks very, very different. A production agent demands clearly defined responsibilities, hard success metrics, and strict operational boundaries. Pragmatically speaking, if your agent lacks these boundaries, how do you even know if it's drifting off course? You just can't evaluate it. If success is vague, failure is basically built into your entire system.
And a massive part of that foundation is your tooling. Most enterprise agents rely heavily on external systems, right? APIs, databases, internal platforms. The real killers of AI projects aren't usually the models. It's inconsistent responses, API timeouts, missing retries, poor error handling, and a total lack of rate limiting. You can have an AI model that reasons flawlessly, but if the external tools it relies on break or time out, the entire outcome is completely ruined. Unreliable tools inevitably lead to unreliable outcomes. It's that simple. Production-grade agents require production-grade tooling.
Moving to Section 2, brains and boundaries, context and strict guardrails.
Giving an AI model pure autonomy without strict governance is an operational nightmare just waiting to happen. We have to control how the agent thinks and how it acts. So, how does it think? Well, it thinks through context. Context management is the absolute fuel that powers intelligent decisions. We're talking about utilizing strategies like retrieval-augmented generation, or RAG, long-term memory, session state management, and injecting user-specific domain knowledge. Why is this totally non-negotiable? Because no model in the world can compensate for missing information. If an agent lacks relevant data, it doesn't just politely stop working. It compensates by making assumptions. It gives you a highly confident yet completely wrong answer. We call that hallucinating. Proper context is what prevents this.
Now, what about how it acts? Look, production agents cannot have unrestricted access to your business operations. We absolutely need essential guardrails in place. I'm talking permission controls, business policies, validation rules, spending limits, and security constraints. Take a real-world example. Let's say you have an agent dealing with customer service. It might determine a refund is appropriate, sure, but generating that actual refund should never, ever happen without secondary validation checks and strict spending limits in place.
Which brings us to Section 3, the operational reality, evaluation, observability, and resilience.
This is the gritty reality of what happens when things inevitably break. Because a few successful demo runs do not prove you are ready for production. Real-world deployments demand continuous evaluation across accuracy, latency, cost, reliability, and safety. If you cannot measure the quality of your system, you literally cannot improve it. Industry expert Ashish Palwa hit the nail on the head. He said, "I have seen more agents fail on observability than on the model itself. Without tracing what the agent actually did, you are debugging blind. This is a hard-learned industry lesson. Observability is what transforms an AI from a terrifying, unpredictable black box into a manageable, professional, operational system."
Imagine you get a P1 alert that the agent just did something completely unexpected. To stop debugging blind, you must be able to answer a few very specific questions immediately. What exactly did the agent see in its prompt? Which specific tools were actually invoked? What reasoning path did it follow? Why was that specific decision made, and what action was ultimately executed? If you don't have trace logging, tool execution tracking, and decision auditing built right in, you're not engineering, you are just guessing.
And a big part of that operational reality is realizing that business workflows are rarely just a straight line. Lots of implementations rely on a single prompt execution and just kind of hope for the best. That will fail. You absolutely need orchestration frameworks to handle resilience. You trigger the workflow, sure, but then you have to manage complex states and fallback paths. You must execute retrial logic if an API suddenly drops. And if it fails completely, you must automatically initiate error recovery or escalate the issue. An AI agent isn't just a prompt. It is a complex workflow that needs serious orchestration.
Finally, Section 4. The Human Safety Net, Human-in-the-Loop Strategy. It is time to completely shatter a very pervasive myth in tech right now. The idea that successful AI means totally removing human beings from the loop. A mature AI agent must know its limits. It has to automatically stop execution to ask for human clarification during high-risk decisions, financial transactions, compliance-sensitive actions, intense customer escalations, really any unique exception handling. The system needs to know exactly when to continue autonomously and exactly when to pause and say, "Hey, I need a human to look at this."
Every tech lead needs to internalize this powerful perspective shift. Human oversight is not a weakness. It is a reliability feature. Incorporating human checks and balances doesn't mean your AI failed. It means your platform is actually trustworthy, accountable, and genuinely ready for enterprise deployment. It ensures the AI is acting safely within its designated parameters at all times. To summarize our core takeaway for today, the future of AI isn't going to be determined by who has access to the most massive, powerful foundation model. Organizations won't win by just deploying smart models. They are going to win by engineering trustworthy, observable, governable, and resilient AI platforms around those models. Production AI is ultimately about reliability, control, and trust, far, far more than it is about raw intelligence.
I want to leave you with this final provocative thought. Take a hard look at your current projects and ask yourself, are you just deploying an intelligent demo that looks great in a nicely controlled environment? Or are you putting in the gritty, essential work to engineer a resilient production system? The difference between the two is everything. Thanks for joining me on this explainer, and keep building responsibly.